Let's take a look at this example. I'm going to start proving that the left side is equal to the right from the left side. We have sine 3 beta over sine beta minus cosine 3 beta over cosine beta. Please notice that we have subtraction of two fractions. In order to subtract fractions, we're supposed to find the common denominator. Common denominator for these two fractions is sine beta times cosine beta. So with the common denominator, these two fractions are going to look like this. We have cosine beta and I have sine, but this time I'm going to rewrite this sine 3 beta as beta plus 2 beta over sine beta cosine beta. Please notice that beta plus 2 beta is equal 3 beta. So this is true. Why I did so? Because I want to apply this formula. Minus, okay, common denominator is sine beta cosine beta, and I have in the numerator sine beta times cosine, and I'm going to rewrite 3 beta as beta plus 2 beta. Next, I'm supposed to again copy cosine beta, and instead of writing sine of the sum of two angles, I'm going to write simply the right side of this formula. What I mean by that? Simply write sine beta cosine 2 beta plus cosine beta sine 2 beta over sine beta cosine beta minus, we have another fraction. We have sine beta times, again, instead of writing cosine of the sum of two angles, I'm going to write cosine beta times cosine 2 beta minus sine beta sine 2 beta. Of course, over the common denominator I have sine beta cosine beta. Next, we're supposed to perform the multiplication. We're supposed to distribute this cosine into the parentheses and this sine into these parentheses. And we are going to have cosine beta sine beta cosine 2 beta plus cosine square beta sine 2 beta minus, I'm going to write everything over one fraction bar, and I'm going to have sine beta cosine beta cosine 2 beta. Negative times negative gives me positive, and I'm going to have sine square beta, and I have sine 2 beta. Everything over sine beta cosine beta. Now let's take a look what we can simplify over here. We have cosine beta, sine beta, cosine 2 beta. And we have sine beta, cosine 2 beta. And we have invisible positive sign and negative sign over here. That's why these two terms are going to subtract each other. And please notice that in these two terms which left, we have common factor, which is sine 2 beta, and we have sine 2 beta. I'm going to factorize this term, this trigonometric function. We have sine 2 beta, and I have inside of the parentheses, I have cosine square beta plus sine square beta over sine beta cosine beta. Now, please notice that we have nothing else, just Pythagorean relation. Cosine square beta plus sine square beta is equal 1. And what we have over here, we have sine of twice of an angle. So I'm going to rewrite this as 2 sine beta cosine beta. I use this formula. And don't forget, this is 1, that's why I don't copy this down, over sine beta cosine beta. Sine beta and sine beta will cancel out, cosine and cosine will cancel out, and I end up with 2 over 1, which is equal 2. In the original identity, on the right side, I have 2. So this is the proof that left side is equal to the right side. Let's take a look at this example. I'm going to start my proof from the right side. Okay, I'm going to copy down this first. I have cosecant square alpha over 2. I can rewrite this as 1 over sine alpha over 2, and everything is raised to the second power. Now, please notice that this is the sine of half an angle. That's why I'm going to use this formula. That's why I have 1 over plus minus square root 1 minus cosine alpha over 2 to the second power. Next, you're supposed to use the properties of exponents and raise the numerator to the second power and the denominator. 1 to the second power is equal 1, and square root to the second power is simply the content which is under the square root. So we have simply 1 divided by 1 minus cosine alpha over 2. Next, we have division. 1 divided by fraction. So what we're supposed to do, we're supposed to convert division to the multiplication. 1 times 2 over 1 minus cosine alpha. This is equal, nothing else, just 2 over 1 minus cosine alpha. Please notice that in the original identity, we have secants. In order to obtain secants, we're supposed to expand this fraction by cosines. So I have cosine alpha and cosine alpha. Please notice that cosine alpha divided by cosine alpha is equal 1. 1 times anything, in this case this fraction, is going to give me the same fraction. Maybe this is going to look a little bit different, but the value is going to have exactly the same. Now, but let's take a look what we are going to do over here. We have 2 over cosine alpha times cosine alpha over 1 minus cosine alpha. Please notice that we have multiplication. Anytime you have multiplication, you can switch the order of the numerators and denominators. Why I keep 2 over cosine, 2 over this cosine, and this cosine over 1 minus cosine alpha? Because on the left side of my original identity, I have 2 secant alpha. 2 over cosine alpha is 2 secant. Now, so this is my numerator, and this is, as I said, let me just maybe make it a little bit simpler. This is 2 over 1 times 1 over cosine alpha. You can rewrite this part like this. And we're supposed to have secant minus 1 in the denominator. But we have cosine alpha over 1 minus cosine alpha, right? So what we're supposed to do over here, we're supposed to bring this fraction to the denominator. How you can do that? Simply change multiplication to division and find the reciprocal of that fraction. So I divide by 1 minus cosine alpha over cosine alpha. So let's take a look what we have. We have 2 over 1 is equal to 1 over cosine alpha is secant alpha, divide by, and let me do everything step by step. You can rewrite this as 1 over cosine alpha minus cosine alpha over cosine alpha. This is equal to secant alpha, and I have 1 divided by cosine alpha is secant alpha minus cosine alpha divided by cosine alpha is equal 1. Let's take a look what we have got. We have 2 secant alpha over secant alpha minus 1, and I have exactly the same expression on the left side of my identity. So it means that we proved that the left side of my identity is equal to the right side.